I'm Mike James, and in this tutorial we're going to use a calculator to help solve a problem on the normal distribution. In this example, the weights of players in a sports league are normally distributed with a mean of 76.6 kilograms. It is known that 80% of the players have weights between 68 and 82 kilograms. The probability that a player weighs less than 68 kilograms is 0.05. Part A. Find the probability that a player weighs more than 82 kilograms. Well, first of all, realize that this question involves the normal distribution, so it's a good idea to draw the normal curve in, which is bell-shaped, and to put in all the information that we're given. So you can see the mean weight is 76.6 at the center of the curve, and 80% of the weights lie between 68 and 82 kilograms. We're given that information, and also the probability that a player has a weight of less than 68 kilograms is 0.05 or 5%. So this makes the first part very easy to do, because we have to find the probability that a player has a weight of more than 82 kilograms, which is given by this area at the top end here. So we could add these two areas together, which is 85%, that is 0.85, and simply subtract that from 1 to give the answer 0.15. Remember that the total area under the curve is 1. Let's move down to the next part of the question, and it says write down the standardized value Z for 68 kilograms. Now 68 kilograms is in this first diagram, and 5% of the players had weights less than 68 kilograms. Now when they're talking about the standardized value Z, it's best to draw the standardized distribution, which again is a bell-shaped curve, but the mean value is 0 and the standard deviation is taken as 1. However, the area to the left of 68 will be the same, which is 5% of this first curve up here, will be the same as this area to the left of a number A, which is going to be the standardized value of 68. So we can find this number A by using the calculator. So I'm going to go into the calculator now and go into calculate mode, hit menu, probability, go down to distributions, and I'm going to choose inverse normal. I'm choosing that because we're given the area and we've got to find the this value of A over here. Now the area is 5%, but we write that as a decimal, 0.05, and because we're talking about the standardized curve, we can leave the mean value as 0 and the standard deviation as 1, so accept those and tab down to OK and hit enter. So that gives the number minus 1.64485, which we can round to minus 1.64, 3 significant figures. Now expect your answer to be negative, because the value of A is to the left of the mean value, which is 0 for the standardized curve. So the standardized value of Z is minus 1.64. Let's move on to part 2. It says hence, so we need to use this result that we've just calculated to do this next part. Hence find the standard deviation of the weights. Well, we also know the standardized value of 68 up here can be found by using this transformation. So Z equals x minus mu over sigma, which is really calculating the number of standard deviations that the value x, which is 68, will be from the mean. So we replace x by 68 minus the mean value, which is 76.6, divided by sigma. That's what we have to find, the standard deviation, sigma. So we simplify the numerator, minus 8.6 divided by sigma, and we can now equate this to this standardized value Z that we found in this part, minus 1.64. So we'll do that next. There it is, minus 1.64 equals minus 8.6 over sigma, and it's quite easy now to find sigma from that by cross multiplying, and we get 5.24 to 3 significant figures. So we know the standard deviation of the weights. So let's go to the next part of the question. And it says to take part in a tournament, a player's weight must be within 1.5 standard deviations of the mean. Part C, Part 1. Find the set of all possible weights of players that take part in the tournament. Well, we need to draw our normal curve again and put in our mean value, mean weight, 76.6. We need to find the two numbers such that they are 1.5 standard deviations away from the mean value. Now I've actually put the answers in here, but here are the calculations. This is how I got 68.74 and 84.46. For the 68.74, I simply took the mean value and subtracted 1.5 multiplied by the standard deviation, 5.24, to get 68.74, gives this value here. And to get the 84.46, I just took the mean value and added 1.5 times the standard deviation to it to get 84.46. So basically, in order for players to take part in this tournament, their weights must be with between 68.74 kilograms and 84.46 kilograms. So that's been summarized here. Part 2. A player is selected at random. Find the probability that the player takes part in the tournament. That is, probability that the player's weight lies between 68.74 and 84.46. Now, you'll need to use the calculator to do this, so I'm going to go into the calculator mode, and I'm going to hit menu again and go down to probability, hit enter, and go down to distributions again, hit enter, and go to normal CDF. We never use normal PDF. Hit enter. Now the lower bound you can take as 68.74 because we want the probability that a player lies between 68.74 and 84.46. That is, his weight lies between those two values. So I'm going to put 68.74 in here. It's the lower bound, and the upper bound 84.46. Now, because I've used these two values, I need to use the original mean weight, which was 76.6, so I'm going to put that in here. I'm not using the standardized values, so I have to change the mean and the standard deviation, and the standard deviation was 5.24. So I tab to OK and press enter, and there's the probability, 0.866386. Now that's one way of doing it. There is another way of doing it as well, and that is to use the standardized curve instead, because if you remember from the question, we need to find the probability that a player's weight lies between 1.5 standard deviations away from the mean value. We can use that sentence and use the standardized curve instead. So we should get the same answer. So I'm going to do that now. Let's go menu, go down to probability, go to distributions, normal CDF again. Now the lower bound this time is minus 1.5 because it's 1.5 standard deviations below the mean for the standardized curve. And the upper bound is 1.5 standard deviations above the mean, so I'm going to put plus 1.5 in. And I leave the mu and the sigma as they are because I'm looking at the standardized curve now. Of course, the mean value is 0, standard deviation is 1, and I'm going to hit tab and press enter. There it is. I get exactly the same result. So, two ways of finding the probability that a player's weight will lie between this given range.